Hello, let's do Advent of Sudoku, Day 8. And if you're not familiar with Advent of Sudoku, then definitely check out the playlist in the description. It starts at Day 1, and in Day 1 I explain all about it and give you a nice intro. So definitely you want to do these in order. But if you are with me on Day 8 and you've done Day 1 through 7, or you just want to jump in and try this one, that's absolutely fine. The link is in the description for the PDF, which updates every day, so just re-download that today and you will have Day 8's link. All right, so today we have an interesting variant. It's called irregular. So instead of having our standard boxes, our standard 3x2 or 2x3 boxes, however you want to think about it, where you place the digits 1 to 6 once each, then we actually still have 6 regions where you place 1 to 6 in them. So we have 6 regions of size 6 where 1 to 6 goes in them once each. But the shapes are irregular. The shapes are whatever the constructor decided they should be. And those are still denoted with these borders, these dark borders around the cells. So like this is one of the regions, this is one of the regions, etc. So we're calling them regions instead of boxes because they aren't boxes anymore, but it's the same thing. And do note that we do not have the normal boxes. Don't try to use the normal boxes, only use the irregular regions, but we do still have the row and the column restrictions that you're used to. So those are the rules. Definitely give this a try and then come back and watch my solve. I'm going to start now. And today I'm finally going to remember to restart at the beginning so that you can get my actual solve time. All right, so the thing you want to look for in irregular very often is geometry. So what do we mean by geometry? Well, I think a good example would be this 5 here, because this 5 sees a half of this region. And so it's taking 5 out of these 3 cells, and we have 2 givens in this region. And so that's going to force the 5 to only go here. But now we can do something even more fun with geometry, because this 1, 3, and 5, they need to go in this row somewhere. But because of our weird irregular shape here, 1, 3, and 5 can't go in these 3 cells or they'd repeat in that region. And so we already have a 5 in the row, but we need a 1 and a 3 to place. This 1 sees up, so we can place 3 and 1. And now we know that these 3 cells are going to be the same as these 3 cells. So they're going to have, and we can just use the box logic to see what they would be, but they're going to be 2, 4, and 6 here. And they're going to be 2 and 4 down here, but this 2 sees over. So we can actually place the 4 and the 2. All right, now we can do a very similar trick here. We have 1, 4, and 2 here. They can't go here, but they must go in the region somewhere. So we need the 4 and the 2 to go down here. This 2 looks down. So that's a 4 and that's a 2. And then what do we have left here? Well, we're going to need a 3. This 3 looks over. And then we're going to need the 5 to finish off that region. And now repeat the same exact trick. 4, 2, and 3 need to go up here somewhere. We have the 3 already. The 2 and the 4 go here. And now this forms a pair. And so with this pair, we can look up and see that this is a 6. And so that actually resolves the 6 in that region. And then we can also just finish this column. I think is probably the easiest thing to do. It needs a 1, so that 1's going to go here. And let's see, what else do we need in this box? We have 1, 2, 3, 4. We need 5 and 6. This 5 looks down, so this is 6 and 5. And it should be pretty clean from here. Let's just try to do this as optimally as possible, maybe. So, what am I seeing? Well, I'm seeing this column here needs a 2 and a 4. This 2 looks over, so that's 4 and 2, and that's a 4. And then we need 3 digits for this region, which is going to be useful because that's going to dictate what this is. Basically, what we can actually do, we can use geometry again if we want. Why not? This column is going to need a 2, but this 2 prevents it from repeating in this region, in these 3 cells. So we know that the 2 is going to go here, and that resolves this 4 and this 2. And then these 3 cells, well, actually, we might as well just finish this row first. That's a 3. These 2 cells now are going to be a 1 and a 6. This 6 tells us which order they go in. And then finally, we should just be able to finish this with the remaining of each digit. So we do need a 1 in here. We need a 3 in here. Because of this 3, couldn't go in these 2. We need a 4 and a 5, and that finishes us off. So with explanation, took me 3 minutes and 7 seconds. Compare your time to mine. And of course, if you enjoyed this, then why not leave a like and subscribe?